Alright, now charge in a uniform electric field. Okay, this part we have 4 cases to discuss. Yeah, 4 cases. So let's talk about the first case. Okay, the first case is a stationary charge. Okay, regarding stationary charge in this uniform electric field, okay, between the parallel plate. So here for this first case, we have also 2 examples. The first one is using a positive test charge. The second example use a negative test charge. Okay. So the first one, the positive test charge. This positive test charge is stationary in between these 2 plates. So what will experience by this test charge? Okay. So if this test charge is between the parallel plate, it is actually inside the electric field of the parallel plate. So this test charge is inside the electric field of the parallel plate. So the force it experiences, of course, is the electric force. It's only the electric force. If we neglect the weight, if we neglect the weight, we just consider the electrostatic force. So the only force experienced by the test charge is the electrostatic force. Okay, so the total force is equal to electrostatic force. So you apply the Newton's second law. Total F equal to ma. Okay, so the only force experienced by the test charge is the electric force. So we substitute inside electrostatic force equal to ma. And we know that electric force equal to Q naught E. Okay, the test charge times electric field strength between the 2 plates. Of course, for the 2 plates, still remember how to find the electric field. To find the electric field of the parallel plate, the uniform electric field between the parallel plate, we use delta V over D. Delta V over D to find the electric field. Okay, and then once you got the delta V over D, the electric field, you multiply by the test charge, you will get the electric force experienced by the test charge. Okay, so you got the Fe. Okay, substitute the Q naught E there. So to find the acceleration, okay, of the test charge, because this test charge is being pulled by the negative plate. This test charge is positive charge. So this test charge is inside the electric field. When this test charge inside the electric field, of course, it will experience electric force. And the direction of the electric force is towards the negative plate. Why is it towards the negative plate? Because a positive charge must be attracted by the negative plate, isn't it? If negative test charge is attracted by positive plate, just like that. Okay. This positive charge is attracted by the negative plate. So the electric force is downwards towards the negative plate. Okay, Fe is downward. So if it has force, it has acceleration. Okay, it has acceleration. So to find the acceleration, this is the way we substitute the formula F equal to QE. QE equal to ma. Because the only force acting on the charge is only the electric force, so that's why it's only Fe. Okay. To find the acceleration of the test charge equal to Q naught E over mass, the mass of the test charge. Okay, so that is how to find the acceleration of the test charge. About the negative, if it is a negative stationary charge, this negative charge must be attracted by the positive plate. So that's why the force is upward towards the positive plate. When the force upward, so the acceleration must be in the same direction with the force. Okay, force go upward, acceleration must also upward. Acceleration must always follow the direction of force. Okay, acceleration always follow the force. Like F, if F is going downward, A also downward. F going upward, A also upward. Okay, because F equal to MA, the A must follow the F. Okay. Another way to see this is still remember what we have learned before in the identifying the electric field. Still remember this one? Still remember this one? If it is a positive test charge, the force and electric field must be in the same direction, But if it is a negative test charge, the force and electric field must be in the opposite direction. Do you see that? You see this one? If it is a positive test charge, force and electric field same direction. But if it is a negative test charge, the force and electric field must be opposite direction. Okay. So we also apply this one into the cases just now. When positive test charge, force and electric field, same direction. Negative test charge, force and electric field, opposite direction. Look back to the case just now. Yeah, I want you to look back to the case just now. Okay, this is the positive plate. This is the positive test charge. Positive test charge, the force and electric field must be in the same direction. This electric field is downward. Why downward? Because electric field always come from positive plate, go to negative plate. Electric field must always come from positive plate, go to negative plate. It originates from positive plate and then end at the negative plate. Okay? So if a positive test charge, the force and electric field, same direction. Another way of saying is positive test charge must be attracted to the negative plate. Okay, if it is a negative test charge, force and electric field must be opposite direction. You see that? Force and electric field opposite direction. Electric field is from positive plate to negative plate, but the force is opposite to the electric field because it is a negative test charge. The negative test charge, force and electric field, opposite direction. Another way of seeing is the negative test charge must be attracted to the positive plate. That's why the force is upward. Okay, I explained a lot. And because it is stationary, the first case is about stationary charge. So the initial velocity is zero. Later, the question will require you to calculate. For example, maybe the question will ask you to calculate. Apply the kinematic equations. Maybe ask you to find the final velocity. So maybe you can apply v square. Maybe the question you can apply v square equal to u square plus 2as, or maybe v equal to u plus at. All the four general kinematic equation you can apply here. Okay, why? If the question asks you to find the final velocity of the test charge, you can use the kinematic equation to find. Okay, the initial velocity is zero for the stationary charge. Initial velocity is zero. Acceleration is q naught e over m. You can find the acceleration. This acceleration is because of the electric force. The test charge pulled by the negative plate, the negative test charge pulled by the positive plate. And then the displacement is maybe if you travel from the positive plate, go to negative plate, S should be the separation between the two plates. And then time maybe at given time. Maybe the question asks you to find time, travel from positive plate to negative plate, or negative plate to positive plate. So that you can find time, you can find many things using the kinematic equations. All right, that's for the first case. Now, how about the second case? The first case is about stationary charge. Now, the second case is the charge is moving perpendicular to the field. Now, the charge is not stationary. The charge now is moving. But it is moving perpendicular to the field. So you guess what will happen? Of course, we know that the positive test charge will be attracted by the negative plate. The negative test charge will be attracted by the positive plate. So the positive test charge will curve towards, because the positive test charge attracted by negative plate, it will curve towards the negative plate. It won't just go straight. It won't just go straight undeflected. It will deflect. It will deflect towards the negative plate. Okay. For the negative test charge, it will deflect. It will deflect towards the positive plate. Okay. The negative test charge will deflect towards the positive plate because it is attracted by the positive plate. Okay, now let's look at the force experienced by the test charge. Because this force is only exists in the y component. If you look at here, this is actually projectile motion. We already learned in the first semester. It's the same thing. It's actually projectile motion. So you apply back the way you solve the projectile motion. You apply back your knowledge into this part. You use back the same method of doing projectile motion in this part. Okay, so we have x component and y component. For the x component, the acceleration is 0. Why acceleration is 0? Why ax is 0? Because this electrostatic force is only in y component. The force is only in y component, so this force only affect the y velocity, the y component of velocity. It won't affect the x component. Still remember what we have learned before in semester 1? We have learned about projectile motion, like the ball. You kick the ball. You kick the ball with the horizontal projectile. You kick the ball with 50 meter per second. So will the ball just go straight forward? No, it will go down this way. It will curve downward. Why is it curve downward? Because what? Because this ball is attracted by the gravitational force, or the weight of gravitational force. This gravitational force is only at the y component. It's only at the y component. The x component has zero velocity. Has zero force. If this one, actually, we have some assumption that we ignore the air resistance. If we ignore the air resistance, so if we ignore the air resistance, basically the x component has no force. If no force, the ax is 0. Ax is 0. But this one, in the y component, Fy equal to Fg. W equal to mg. So W equal to mg. So our Fy is may. You understand that? Fy equal to may. Just cut off the mass. Our acceleration y is equal to, we put the direction. Actually, we should need to put the direction, negative g. That's why our acceleration in y component is negative g, affected by gravity. Last time we talked about gravity. The gravity as our acceleration in y component. That's why when we talk, I just want you to recall back what you have learned in projectile motion. Our ax is 0. That's why our velocity in x component is always constant. But But for the y component, the velocity in y component is always changing. It's not constant. It's changing because in y component we have acceleration, but in x component our acceleration is 0. Velocity is constant in x component. Velocity in y component is changing because of the gravity, because of the acceleration in y component. In fact, the Vx is constant is equal to Ux, isn't it? Okay. But in y component, we have Vy changing, where Vy equal to Ut plus half Ayt square, Ay, no, sorry, I'm wrong. So I'm so sorry, I mess up, yeah? V equal to U plus At, V equal to U plus At in y component. So we have acceleration in y component. That's why our velocity changing. Yeah, we have acceleration in y component. That's why our velocity is changing. So now, last time we talked about acceleration due to gravity. Now is acceleration due to electric field. We no longer talk about gravity. Now negative g we change to what? Negative g we change to Q naught E over M. It's the same thing. We use the same method to do. It's just that to find the acceleration in y component is not equal to negative g anymore because we not talk about gravitational force. We are not talking about gravitational force. The force in y component now is the electrostatic force, not the gravitational force, Fg. It's the Fe. It's not Fg, it's the Fe, electrostatic force. So to find the acceleration in y component, now how to find? Just like in x component force is 0, Ax is 0. Y component, the force is the electrostatic force. Fy equal to May. So just substitute with Fe equal to May. Fe again is Q naught E, the same as before. Yeah, the same as before. Fe equal to Q naught E. So to find the Ay is Q naught E over M. It's the same formula as this one. It's just that this one is only affect the y component. Yeah, affect the y component, but it's still the same thing. Okay, so the Ay is equal to Q naught E over M. Okay, so instead of negative g, now is Q naught E over M. So we get the Ay. Once we got the Ay, we can do all sort of projectile motions calculations. Like if you want to find the, the final velocity, Vy equal to Uy plus Ayt. You can do that in the y component because we already have the Ay. You can find the Vy, the final velocity in y component. For the x component, Ax is 0. Again, Ax is 0. Vx equal to Ux. So it's not changing. Vx is still Ux. So once we know the Vx and Ux, we can find the final velocity at mid-air, which you take both components, Vx squared plus Vy squared. You can get the final velocity. That's for magnitude. And then, of course, you need to find direction. You need to do the tangent theta, Vy over Vx. That's it, to find the theta above the positive x-axis, below the positive x-axis, and that's it. Okay, you also can find the s, for the x component, you can do the what? Do the sx equal to uxt plus half axt squared. But of course, because ax is 0, that's why sx equal to uxt only. You can find the time, you can find the time. Here. You can substitute once you got the time. You know how to find the sx? Because the sx is actually the length of parallel plate. the length of parallel plate is how far the distance travel in horizontal distance. Sx is actually the length of parallel plate, and Sy not necessarily the separation of parallel plate, not necessarily the separation between the parallel plate. One thing you must be careful. One thing you must be careful here. Don't go into this trap. The separation between the two plates is d. This d is not necessary Sy. It's not necessary Sy because the charge doesn't come from at one plate to the other plate. Yeah, maybe the charge enter at the middle. Like this, you see, this charge is not entering from one side of the plate. It's actually enter somewhere around the middle. So you see, like this one, maybe I should show this way. You know, okay. Okay. You see, I want you to see. Maybe the charge. This is the positive plate, and this is the negative plate. You know, maybe enter over here, go to here. You see that? So the Sy is the Sy. This is the Sy. But this separation between the plate is d. So you see, the charge, it doesn't come in from the one side of the plate. It come in from the middle. Coming from the middle. So the Sy is only this amount. Only this amount. It's not the whole d. It's not the whole separation. So you can never cannot regard d as Sy. Yeah, cannot regard the separation between the plate as Sy. No. Yeah, because the charge, it does not enter from one side of the plate. It maybe enter at the middle, somewhere maybe 1/4 of it. Maybe enter over here, maybe enter over here. I don't know. Okay. So d is not Sy. That's all. Okay, d is not Sy. So in the end, what I want to say is you can do all sorts of projectile calculation. Okay. In this example, so of course in y component you do the s equal to ut plus half at square also. This is the y component. Okay, so once you got the time here, you can substitute over here because they have the projectile motion. They have the same time. Remember, the tx must be equal to ty at all positions. The time must be the same for both components because for projectile motion, both components happen simultaneously. So they share the same time. Once you get the time from x component, you can transfer the time information to the y component to find the next info you need. For example, maybe you want to find you use the time to find the vy, you use the time to find the sy. That's it. Okay, you can also find the final velocity. So that's all for I will show you more about this in the problems videos. Yeah, so please look out the videos on the problems, yeah, regarding this projectile motion for charge moving perpendicular to the field. Look out for the videos. Okay, I will prepare for you. So please look out the videos how to solve projectile motion for charge in a uniform electric field. Okay, that's all for this one. And for the third case, is a charge moving parallel to the field. Charge moving parallel to the field is almost the same as the stationary charge. It's just that the stationary charge has the zero initial velocity, but the charge moving parallel to field has initial velocity. It has the initial velocity. The initial velocity is not zero. Yeah, initial velocity is not zero. Okay. So the same thing. The force is still only the electrostatic force. We neglect the weight. We only take the electrostatic force. So electrostatic force equal to ma. In the end, acceleration is still q naught e over m. Okay, it's the same thing as above. Okay, the positive charge should attract to the negative plate. And then yeah, this is both positive test charge. Okay, both attracted to the positive plate. Here the only difference is, you just want to show you the difference is this one, the positive charge is moving towards the initial velocity, is moving towards the negative plate. This positive test charge is moving towards the positive plate. So what will happen? Okay, what will happen? You see the force and velocity in the same direction. This one force and velocity in the same direction. And this one force and velocity in the opposite direction. What will happen? Yeah, I want you to look carefully. What will happen? Okay. Okay, both of these are positive test charge, both attracted to the positive plate. So both the forces is downward. Both forces is downward. So when the force is downward, okay, force is downward, acceleration also downward. Because acceleration follow the force. Understand? Force downward, acceleration also downward, because acceleration follow the force. So now, for the first one, this charge is moving towards the negative plate. Velocity is downward. So velocity is downward. So velocity downward, acceleration downward. When both velocity and acceleration same direction, then velocity and acceleration same direction, they will accelerate. Okay, it's just like the acceleration is helping the velocity. It's helping the velocity because same direction. It's helping the velocity. So of course it will accelerate the object. The force also same direction as the velocity. It's like helping the velocity. It's like you press the you press the pedal. So you accelerate your force is in the same direction as the velocity. Acceleration same direction as the velocity. Both acceleration is helping the velocity. So of course this object will accelerate. But this one, the velocity is upward. Acceleration is downward. Acceleration is not helping the velocity. The force is opposite the velocity. It's like friction, it's like frictional force. This one same direction. This force is like force of the motor. This one is like frictional force, opposite the motion. The force is opposite the motion. Velocity is the motion. Force is opposite the motion. Acceleration is opposite the motion. Yeah, it's not helping because in opposite acceleration is opposite the velocity in opposite direction. So when V and A opposite direction, this object will decelerate. It's like you pressing the brake. It's pressing the brake. When you're pressing the brake, you have friction going behind, oppose the motion. So this object will decelerate. Okay, so when velocity and acceleration same direction, accelerate. When velocity and acceleration opposite direction, this object will decelerate. Okay. So again, you also can apply the formula v squared equal to u squared plus 2as, v equal to u plus at, and s equal to ut plus half at squared for this situation, to find any information the question asks. Yeah, you want to find the displacement, you want to find a final velocity, you want to find the time taken. You can use the kinematic equation. The acceleration, you can find from this formula, you can find the acceleration of this charge. This acceleration is caused by the electric force. Okay, I can find the acceleration by using Q naught E over M. You can find the acceleration here to use in the kinematic equation, like v square equal to u square plus 2as. This acceleration here, this acceleration here is calculated using this formula. Okay. Okay, and then lastly, the last case is charge in a dynamic equilibrium. Charge in a dynamic equilibrium. For example, now you have two force. You have two force exist. Last time is only one force, only the electric force. Now, what if you have two force and both force equal? This dynamic equilibrium must have two force equal but opposite direction. Okay. Now you have electric force and weight. Last time don't consider the weight, isn't it? No weight is considered. No weight is considered. Only the electric force. Now you have the weight. What will happen? What will happen? Like this, the second case, you only have the electric force. When you only have the electric force, of course, the object will, the test charge will curve either to negative plate or positive plate. Okay, it will curve. It will deflect. Okay, it will deflect. But now you have two forces in opposite direction. This test charge will go undeflected. It will go undeflected if the electrostatic force is equal to the weight. Last time we don't consider the weight. If we don't consider the weight, you will have projectile motion. You will have projectile motion because only one force. But if you consider the weight also, and also the weight equal to the electric force equal, then they both cancel off. They both cancel off. So the total Fy is equal to 0. Total Fy equal to 0. So this, you won't get a projectile motion. There's no projectile motion. This object will go straight undeflected. It will go straight undeflected. So again, total Fx is 0, Ax 0, total Fy also 0, Ay also 0. Unlike this one, Ay you have certain value. This one Ay is 0. Y 0 because Fe equal to weight. Total Fy equals 0 because the electric force equal to the weight. Here we get another formula. Fe is Q naught E. Yeah, F equal to Q naught E. Weight is mg. So Q naught E equal to mg. Maybe the question will ask you to find. The mass of the test charge. How do we find the mass of test charge? Use this formula. Q naught E over the gravitational field strength. So you can find the mass of test charge. Okay. So if you have the two force in opposite direction, weight downward, of course weight downward. This one weight is downward, and this is the negative test charge. It is attracted to the positive plate. That's why the electrostatic force is upward. Okay, upward. So the electric force and weight become opposite direction. When opposite direction, and some more, if they are equal, they cancel totally. So the total Fy equal to 0. The charge will go undeflected. Undeflected. Okay, so that's all for the 4 cases. That's how you find the acceleration. Okay, using this formula, using the concept. Yeah, start from here. You can find the acceleration, and this part always asks about the kinematic equation. You need to apply the 4 kinematic equation: v equal to u plus at, s equal to ut plus half at squared. All that formula. And sometimes the question will ask about projectile motion. You need to apply your projectile knowledge. So I will give you videos on this part. Okay, please check out the videos for charge in a uniform electric field problem solution section. Okay, that's all for our summary. Thank you for watching. Bye.